Hello everyone. In this video, we are going to discuss about 2014 GATE question on out of plane eccentric bolted connection. See the next question on bolted connection. So this is a diagram. Okay, since the diagram, first try to observe the diagram clearly with the diagram. Okay, by understanding, by observing, and after that understanding the diagram, we can solve this question very easily. So first see the question. Okay, later I'll explain about diagram also. First go through the diagram and see the question. Now what is asking based on this diagram is asking find the tension and shear force in kilonewton in each bolt. Okay, now he's asking us to find tension and shear force in kilonewton. As I said, newtons are units are very important. So now he's asking us to find tension and shear force in kilonewton in each bolt. And options are also mentioned. Okay, options are also mentioned. We need to choose the right option. So this question is for 2 marks. Okay, this question is for 2 marks. So let us see here. Okay, let us see the diagram. If you see the diagram, this is a I section column. Okay, I section used as a column. So this is the I section. I section. Okay, I section. Now to this I section, okay, to this I section, 2 flanges will be there and 1 web will be there. Now to one flange of I section, to one flange of an I section, bracket is connected by making use of bolts. Now connection details we can clearly see in this view. So it means basically this is a front view and this is a side view. So this is a front view. And this is a side view, right? Clear. In side view, we can observe the connection details clearly. It means 2 lines of bolts are there, and in each line there exists 3 bolts. Means total 6 number of bolts are there. In the given connection or in the given question, there exist 6 bolts which are used to connect this bracket to this flange of an I section. Now he is asking us to find tension and shear force in each bolt. Clear. So for that we have to go to the loading details. For that we have to observe or we have to go through the loading details. So what is the load here? 250 kilonewton, which is acting in this direction, right? Which is acting in this direction, means it is somewhat inclined to the horizontal, or you can say vertical also. Okay, it is having some inclination with horizontal, means the load is neither horizontal nor vertical. Hence we need to resolve it. Hence we need to resolve this given load in 2 directions. What are those 2 directions? Horizontal direction. So this is one direction. So in this diagram itself I will show. This is one direction and this is other direction. Clear now, everyone? Now this horizontal direction, okay, this horizontal direction is perpendicular or normal to the weld group. Sorry, normal to the bolt group. Is that okay? So this particular horizontal component, okay, this particular horizontal resolution or horizontal component of this load, okay, of this load is normal or perpendicular to the bolt group, and this vertical, okay, this vertical component, okay, this vertical component of the load is tangential or parallel to the bolt group. And we know tangential force always causes shear and normal force always causes tension if it is away from the bolt group. If it is towards, it causes compression. But in this question, this normal force is away from the bolt group, therefore it creates tension, and tangential force always creates or causes shear. Now he is asking us to find that shear and tension. Okay, so for that we need to calculate this angle theta. So let us consider this angle as theta. Okay, let us consider that angle as theta. So now in that sin theta, if you take sin theta, what is sin theta? Sin theta is opposite by hypotenuse. Now this is opposite side. How much the mention in the question? 3, and hypotenuse here is 5. So sin theta is 3 by 5. In the same way cos theta. So cos theta is adjacent side by hypotenuse, that is 4 by 5, which is very clear in the diagram. Okay, which is very clear in the diagram. Now tangential component. So this is a tangential component. How much is tangential component? So tangential component of this 250 is nothing but 250 sin theta, and normal component of this 250 is 250 cos theta. Is that clear? So this 250 cos theta is a total force. Okay, this 250 cos theta is acting a total normal force acting on all these bolts. Okay, acting on all these bolts. Now for each bolt we need to divide it by 6. In the same way, this 250 sin theta is the total tangential force acting on this 6 number of bolts, or total number of bolts. Therefore, to get shear force on each bolt, we need to divide that force by 6. Is that okay now, everyone? Now, tension force. Very simple question. Even though it is asked for 2 marks, but very simple. So, tension force on each bolt is equal to 250 cos theta, directly I'll write here, 4 by 5 divided by 6. Is that clear? So this is what the tension force. Upon simplifying, we are going to get it as 33.33 kilonewton. This is the tension force. Now coming to the shear force. Shear force on each bolt. Shear force on each bolt is 250 sin theta. Sin theta is nothing but 3 by 5 by 6. Upon simplifying, we'll get this as 25 kilonewton. So tension force on each bolt is 33.33 kilonewton and shear force on each bolt is 25 kilonewton. Then obviously the correct option is fourth option. Okay, correct option is fourth option. Take it out.